Okay, really good. A couple of you might have stopped if I seen that there was one that was a wrong exponent. The biggest thing is making sure you get your exponents correct. The way I do it, I will always put a 1 in front of the bigger unit when I have to convert, and that way I know all my exponents are going to be positive. Okay? That way I don't have to guess. Like some of you missed 1 or 2 just because you're thinking one way. I think most of you realize what you needed to do, but sometimes it can get a little confusing. So that's kind of what you did. You just compared them and you set them equal. That's the most important thing that you need to do when doing these type of problems. So let's just go through the answers real quick, and I'll point out a couple for you that we can do. So 1 is in front of the smaller unit, the centimeters to the minus second. So what I like doing, you don't have to do it, but I always just put the exponent that goes with that measurement in comparison. So that's centimeters minus 2. So it's a minus 2, and that's 0. So the difference is 2. The 1's in front of those smaller units, so that'd be 1 times 10 to the minus 2. Right? Kilo, 3. That one, 0. This can also help you see, what the 1 is, if it's in front of the bigger unit or not. So definitely a 3 exponent's bigger than a 0, so then this would be 1 times 10 to the third. That one is 6. 10 to the 6, that one's 10 to the 0. Difference is 6, so it'll be 1 times 10 to the 6. Meter is 0. Millimeter is a negative 3. So again, that's in front of the bigger exponent. So that would be 1,000, or 1 times 10 to the third. Really appreciate you guys are putting them in scientific notation. I think that's going to benefit you more than just putting them in standard form. 1 is in front of the bigger unit, that's 0. This is minus 6, so or minus 6. And so that would be 1 times 10 to the 6. 1's in front of the smaller unit on this one, that one's 0. So then this would be 1 times 10 to the minus 9. Kiloliter to liter, that should be 1 times 10 to the third. Grams to gigagrams, this is 0. This is to the 9. So now the 1's in front of the smaller unit, so this would be 1 times 10 to the minus 9. Meters or nanometers, this would be 0 minus 9, so that would be 1 times 10 to the 9th. And then on this one, this is negative 1, this is 0, so that would be 1 times 10 to the minus 1. Okay? So you can look those over. Any questions you guys have on those? So this allows us to set up conversions. Yes, ma'am?
So if there's a 1 in front of the smaller unit, then it's a negative?
If there's a 1 in front of the smaller unit, it's negative. Yep. And I won't, and from now on, I'm always going to put 1. When I do conversion, I always put 1 in front of the bigger unit. And then that way, I'm never going to guess. I'm always, like if you're doing it, and you always put a 1 in front of the bigger unit, your exponents are always going to be positive. You look at the difference, it's always going to be the positive difference of that, exponent-wise. Okay? So, we're gonna practice a little bit on conversions here. So, things we can do now is set these up to find what the new measurement would be with the new unit. Okay? Don't move the decimal. There are students that will get in trouble later on in the year where you can't move the decimal to do the calculation. So that's an easy way. It's kind of a shortcut, and it doesn't work on a lot of things. Okay, most things it doesn't work on. So my suggestion is not to do that. So we're going to just do some practice. You guys know you're getting to know your exponents better and their comparison, and that's good. You got to practice 10 of those. So what we'll do is just called the factor label method. That's all this is called. A lot of times you learn it by what they call the railroad tracks. That's not really a good scientific, you go to college and you say railroad tracks, they're probably like, they might understand a little bit, but they're just conversion ratios that you use. And this is just a way to kind of divide all your units up. Okay? So that's kind of what we'll use if we have multiple steps. Alright, so we're going to go ahead and do one. So we're just going to go ahead. I'm going to put this in scientific notation right away. So I'm going to convert it. I'm going to go 5.0 times 10 to the negative third kilometers. The reason I put it in scientific notation, it allows me to multiply and divide easier. Okay? That's why that I'm going to choose to do that. So everybody's done conversions. Every year, students seem to have a better idea of what they're doing. So can you guys help me with the next step and tell me where the units are supposed to go? So what unit is supposed to be divided here? What's that? It has to be the same. I need to get rid of that unit. No way I can get rid of that unit is I need to divide it out. Does that make sense? So I got to it's math. You divide units out. So I got to get rid of that unit, so that goes down there. If you notice, I didn't put a number with it yet. That's the way I teach it. That's the way I usually do it. I can put my numbers in later. So then up above, I put my meters. So now, guess what? What you did for today, you just transfer into these two spots. You look at meters, you look at kilometers, and then what I do is I take and look at the two, put a number 1 in front of the bigger unit. So which one's bigger? Kilometers or meters? Kilometers. So I put a 1 there. The difference is how much? 3, right? Exponent of 3. So then this becomes what? 1 times 10 to the third. Right? You're used to putting in 1,000. I need you to think exponents, because exponents will make it so easy to do. Because right away you go, I remember what I need to do when I multiply exponents. What do you need to do? You add them. So minus 3 plus 3 is 0, right? So this becomes 5.0 times 10 to the 0, which is 5.0 meters. Pretty easy, huh? With exponents, you don't have to do really any calculations on your calculator. It's that simple. So any thoughts or questions that you have? If you don't do that, okay, so if you don't put this in scientific notation, and everybody should know how to do that, it becomes where you got to plug it now. You got to plug it in on your calculator. Okay, then you got to take 0.0050 times 1,000. If you want to do that, that's up to you. Hopefully, you get comfortable of doing some of these problems, and you don't have to worry about that. Why don't I see if you guys can set this one up based upon the one I just did. This is 51,000 nanometers, and you're going to meters. So it should be just a one-step setup. Some of these are multiple steps, depending upon how you're comparing them, of just putting everything in scientific when we could. You're never going to get counted wrong if you put it in scientific, okay? Notation. So this would be 5.1 times 10 to the fourth. So down here I'm going to put nanometers, and up above I'm going to put meters. So then, now I look which one's bigger, meter or nanometer. I just put a 1 in front of meter, and then this will be a positive exponent, and it should be 1 times 10 to the 9th, correct? So you did that for today, and we're just putting it in a conversion factor. That's what that's called, a conversion factor. Nanometers cancel out, and when we divide, we subtract. So 4 minus 9 is negative 5. So it becomes 5.1 times 10 to the negative 5th. Does that make sense? 5. This number will never change in converting metric. When you convert metric, this number stays constant. The only thing it changes is your exponent. So when we divide exponents, they subtract. So 4 minus 9 is minus 5. And then that would be meters. Okay. I'm going to have you do, since we're going through this pretty quick, I'm going to have you do one more just to see where you're comfortable at comparing. Okay? And hopefully you can not look at your conversion chart all the time. Hopefully you can see what you think it is, look at it, and kind of get that process of memorizing as you go through. So. So go to grams. And I put it in scientific notation for you. That's kind of nice when it's already in scientific notation that you have it in. So try that one. Is that what you guys got? Okay. So 8 minus 6 is 2. So we're left over with 2. And that's what you get. All right. What happens if you have to cross units? Okay. What if we go across that base unit? And so I'll do the first one for you, and then maybe have you do a second one just to practice. So I'll show it two ways. The second way you can ignore if you don't, if you're used to doing it in multiple steps. If you want to do it in one step, I can show it in one step for those who would like to do that or like to see it anyway. So this would be in centimeters. So what I need to do if I go across the base unit where the base unit's not involved, I'm just going to go my first unit to the base unit. So centimeters to meters. So there's a 1 meter is bigger than a centimeter, and centis 10 to the minus second. So there'd be 1 times 10 to the second, or 100 centimeters in a meter. So now I'm at meters. Centimeters cancel out. The next step is to go meters to megameters. Megameters bigger, 1. And so that should be 1 times 10 to the 6th. So now all I have to do is, I know this number is going to be the same. So it's going to be 7.3. I just have to figure out my exponent. So I'm going to take 5 minus 2 is 3. Then I'll do the next one. 3 is left over. 3 minus 6 is minus 3. So it'll be 7.3 times 10 to the minus 3 megameters. Okay? So all I've done, and I put my units in, and then I can put in my numbers wherever the unit's bigger. And if you notice, exponents are never going to be negative. So I'm going to have you do that one. This is gigaliters, that's milliliters. Okay, gigaliters, milliliters. So try your hand at that one. It should be 2 steps. I didn't show you I'll show you the alternative doing 1 step on this next one. Okay. Gigaliters to liters. Gigaliters bigger, so 1. And so this would be 1 times 10 to the 9th. Next one, liter to milliliter. Okay? So I go to the base unit, then I go from the base unit to milliliters. 1 in front of the bigger unit. And then this is 1 times 10 to the 3rd. So basically, you're taking the exponent of a minus 3 plus 12. So your answer is going to be times 10 to the what? 6, right? And that's milliliters. So minus 6 plus 9 is plus 3 is 6. 6.3 times 10 to the 6. And that's what you get. Don't put negatives down because we're always putting 1 in front of the bigger unit. If you choose to do it the other way, that's up to you. I'm not going to show that because I want to be consistent on showing these. So, okay, all right. Now, if you have your handbook, you can turn to page 134, and we've got metric to English, English to metric. We won't do that. We won't do that very much at all. What I say, the sooner you can change the English to metric, that could be 1 step or it could be a couple steps. The sooner you can do that, the easier it is, in which the fewer steps you're going to need. Okay? So you can go like miles to feet, and then you can go feet to meters, and you go meters to decimeters you want, but that kind of adds in an extra step. So if I was doing this one, and I was looking at this chart, I'd find miles and see if there's a conversion to the metric. Is there a conversion to the metric from miles? You see anything on there? There's 2 sides. The left side has numbers, and then the right side also has some different numbers. Okay? So, I don't care which side you use, you just have to make sure you know how to use it. So I'm going to go 7.4 times 10 to the minus 3rd miles. We've got to go miles down here. So what's a good conversion to go to? Is there a kilometer one? Okay, so that one's going to be a good one. So I'm going to put kilometers here. Now, on the left side, if you use the left side, okay, and you find miles. The left side, that each one of those are 1, and then it compares it to a number with the metric unit. So the left side always has 1 with the English unit. So on the left side, those are all 1s, all the way down. 1 square inch, 1 square foot, 1 square mile, 1 acre, all the way down. 1 gallon at the bottom. Those are all 1. And then it compares it to the kilometers, and that would be 1.61. Okay, that's how you use it. If you use the other side, then it does it metrics all 1. Okay, and on that side you put 1 kilometer is equal to 0.62 miles. So I'm to miles. Okay, what's the next step do you think we can do? So I got kilometers to what? To meters. So 1 in front of the bigger unit. This would be 1 times 10 to the third. Then here I'm going to put meters, and I'm going to go to decimeter. Which one's bigger? Meters. So this would be 1 times 10 to the what? First. So then I might have to get my calculator out. I wouldn't have to. I could probably multiply that out, but it would be quicker. So when I take the top line, I get 11 point, and I'll adjust the digits later. 11.9 times 10, what's going to be my exponent? To the first. Minus 3 plus 3 is 0, plus 1 is 1. So times 10 to the first. Then I'm going to have to move my decimal over. And actually, there's 2 digits here, so I should have only 2 in my answer. Now, here's something I haven't told you yet. Conversions never limit your answer. So anytime you do a conversion, like 1 kilometer to 1,000 meters, or 1 meter to 10 decimeters, you don't end up with one significant digit. So conversion ratios never limit your answer. It's always the first one. So this should be 1.19 times 10 to the second, but we only can show 2 digits, so that should be 1.2 times 10 to the second. Okay? So when we move it over, we add an exponent. And that's how you do a conversion from English to metric. And you've done, I think you've done, at least the things I've seen in the past, you've done quite a bit of work doing it, English to metric and that. So I'm going to leave it at that. And I'm going to give you this sheet, worksheet. There's 19 of them on there, but this is due on Monday. Okay? And so you've got a couple days plus, well, Tuesday. So